This is a video of the GIT XA1 glove integrity tester manufactured by Dynamic Design Pharma. This video intends to show the functionality of the system via looking at the operator interface touchscreen control device. What you're looking at right now is the home screen of the tester. What you see on there is a number of buttons and displays. These are the buttons that pretty much are used to control the system. The top button being the cycle control button, and that's the button that the operator would use to access the leak test cycle control screen. The other buttons are parameters, system tests, utilities, and security, and those buttons are accessed only if a person or an individual is logged in at a high enough security level. The system has three different security levels. An operator level, which allows you to do the leak testing process, and that's about it. And then the supervisor level that allows you access to all functionalities of the system except for password management for the security part, which is designated to be accessed only by the administrator, and there's only one administrator level. So in order to demonstrate the system, I'm going to log in as a supervisor, and what I'm going to do is do a login supervisor. And what we have in here is a generic password for now. So now I'm logged in as supervisor, and my name was assigned as Soup1, but basically it is the actual person's name. that functionality is programmed by the administrator. So now that I'm logged in as a supervisor, I can clearly have access to the cycle control, but I also have access to the other functions. One of the functions I want to demonstrate is the parameters function. So I'm going to go in and go into the parameters management. The parameters management allows you to program 5 different recipes of parameters, as you can see, there are 1, 2, 3, 4, and 5 recipes, and these are the various parameters of the system. The top 4 are pressure parameters, such as pressure maximum, the overpressure, which is the pressure that is used to stretch the glove rubber during when it's inflated, stabilization pressure, and the pass-fail pressure. And the other parameters are basically time parameters: inflate time, time to stabilize, and time to actually do the leak test. Also, we have a functionality where we identify what kind of test we're going to run. Are we going to run a glove, or we're going to run a gauntlet? Because there are subtle changes in the way the leak test process performs depending on whether you're running a glove or a gauntlet. There are other functions down here, such as, for example, this allows you to see, to program for the various recipes a descriptor of what the glove type that you're processing. Let's say it's a neoprene or hypalon, for example, that sort of thing. You can also obviously print all these parameters, and if you make a change to the parameters, then you can save them. So that's the parameters part. After the parameters, we can go into cycle control. Now I'm logged in as a supervisor, so I can definitely have access to the cycle control, but if I were logged in as an operator, I would still be able to do that. So under cycle control, we have the ability to program in which recipe we're going to process. So let's say we're going to do a process of using recipe number 2 because we are running glove style number 2. Then we go in and put in number 2. That goes in here. That's the active recipe. That's the new recipe. If I like that selection, then I say confirm recipe change, and of course that information gets plugged in there. At this point, I can start a cycle, and what we have connected to the system just for this demonstration is just a dummy glove. And while this is running, I want to show what goes on. The system is inflating right now. As you can see, it says inflate. Basically, the system inflates the test glove until a certain programmed pressure is reached. Once that pressure is reached, then the system starts what we call the stabilization pressure, which is a pulsing phase during which we pretty much stretch the rubber of the glove to what we desire. And this, you will see, once this is reached a certain pressure, this will switch to stab. In fact, the stabilization, and you can hear the pulsing that it goes on right now. This will, we have very shortened leak test times and stabilization times programmed in for the sake of demonstration, but basically this could be a minute, it could be a minute and a half, whatever it is that the parameters dictate. After this is complete, this phase is complete, we're going to deflate to the starting pressure. Basically, we have stretched the rubber, and now we're deflating the glove to the starting point of the leak test. And that point has been reached, and it's going through a leak test process. You can see the phase time is counting down to 0. The total leak test time is 87 seconds. As I said, you know, these are very short times. And it's indicating that it's a passing test. In other words, the glove is integral. At this point, we would like to be able to output the data off of the test. And what we have here is a glove ID number and an isolator ID number. As you can see that they are in red. That means the numbers have not been entered. So I'm going to put in, let's see, number 1 here, and we're dealing with isolator number 10. As soon as that happens, they turn green and the output results screen comes on. And at this point, I'm going to press the button. What's going to happen here is I have, and I will show afterwards, I have programmed to output to the local printer, which is located on the tester itself. I have a couple other options which I'll demonstrate in a second. So I'm going to go ahead and press the output results and switch. The information that is printed on here, I will describe it. Basically, the information that is printed is the login information, also the active recipe, the basic parameters that were used to run the test, and ultimately the test cycle results. So this is the data packet that can be that is outputted from the system. I'm going to go back to the home screen because this is the area that shows how we outputted the data. We have 3 options. One option is to output it locally, which is what I just did. Basically, the local thermal printer outputs the data information that I described. Also, you can program it to output it in a remote fashion by outputting to a network printer via an Ethernet connection. And then the last approach or method of outputting the data is to store it internally to the OIT. Once you connect a laptop or a flash drive to the USB port that is located in the back of the machine, then you can download the data as a CSV file using basically a Windows environment. It looks like just another drive. So that's a very easy way to output the information out of the unit. So this is an overall description of the system and the things that it can do, that's pretty much it. Thank you.